My name is Chemisty Lab, and I did experiment 5, rates of chemical reaction. There are many reasons why this experiment relates to real life. The first one is enzymes. Enzymes are biological catalysts, and they quicken at the rate of which food is broken down. Another one is washing clothes. The temperature affects the rate of the reaction. And the third one is fridges. At lower temperatures, the rate of the reaction is less, and the fridge reaction happens slower, so food rots slower. The purpose of this experiment was to determine the rate of the reaction of oxalic acid and potassium permanganate. We did 3 different experiments. We varied water, and temperature was constant, and the concentration was also varied. The rate was found by measuring the time it took the purple color to disappear in the spec 20 and for the transmittance to reach 30%. What we did was for the first trial, we took 6 milliliters of water and 5 milliliters of oxalic acid. We mixed that, and then one molarity of KMNO4 was added. Right when that was added, we had to start the timer, and it was placed in the spec 20 to see the absorbency. And we stopped the timer the second it hit 30% transmittance. This was repeated for all 3 trials. This is a table, as you can see, of all 3 trials. In each trial, the milliliters of KMNO4, water, and oxalic acid was varied. And for the stock solutions, right here, 0.130 molarity of KMNO4 was used, and 0.755 milliliters of oxalic acid, and the room temperature was 20 degrees Celsius. This is the second table, and what I did was after trial, we recorded the seconds it took for it to reach 30% transmittance, and then we recorded the average time, and we only did two trials of it. For the observations of the reaction, when KMNO4 was added, the liquid became really dark, and as time began, the dark color started to turn lighter after the 30% transmittance. For calculations, we had to determine the concentrations of KMNO4 and oxalic acid at the start of the reaction. What we did was we took the stock solution concentration of 0.130 molarity, and we multiplied it by 1 milliliter of the starting off volume for KMNO4. And then we divided it by 12 milliliters because that was the overall milliliters that we used in the solution. And the molarity ended up being 0.0180 molarity. And we did the same thing for oxalic acid. We took the starting stock solution molarity, which is 0.755, and we multiplied it by 5 milliliters, which was what we started off for oxalic acid. And then we divided it by 12 milliliters, which was the total. And we got 0.315 molarities. Then we were to find the rate of each experiment. How we did that was we took the initial concentration of KMNO4 and divided it by the time in seconds of the trial. And for the first one, I got 4.05 times 10 to the negative 5th, 1 over molarity per second. And we did that for all 3 experiments right here. This table shows the concentration starting off of KMNO4, oxalic acid, and the rate and rate constant of all 3 trials. For the other calculations, we had to determine the order of the reaction. And how we did that was I set up the first 2 trials. So it was 4.5 times 10 to the negative 5th equals 0.0108 to the x times 0.315 to the y. And then below that was the trial below that. And what we had to do was we had to cancel out the x's in order to find the order of reaction for y. And I did that by dividing these 2 and dividing right here. And then you do the log of each one and divide it to get what y equals, which is 1. I do that for the other one to get x too. And then we were to find the rate constant, the overall rate constant for all 3 trials. And we did that by, I took the first one, which was 4.05 times 10 to the negative 5th equals k times the concentration of KMNO4, which was 0.0108, and the concentration of oxalic acid, which was 0.315. And I ended up getting 0.0119. The overall reaction, or the order of each reaction was 1. So that makes the overall reaction to be 2, to be second order. And I found the overall rate constant was calculated to be 0.0108, 1 over milliliter per second. And the overall rate equation right here is 0.0108 times the concentration of KMnO4 and times the concentration of oxalic acid. In this experiment, there could be some possible errors. For example, you could fail to put the correct amount of solution in each, or molarity in each solution, or you could fail to mix it correctly before you put it in the spec 20, or you could fail to time it correctly, either start it or end it, and that would alter your results, and it could eventually lower the overall rate of reaction in the end, what you calculate. And those are my